Hello, I'm Sulaiman Ivanadda from MS College School of Hall. Today's topic we shall look at work, energy, and power, and these are the objectives of this lesson. By the end of this lesson, learners should be able to define work and energy, calculate work done, and distinguish kinetic energy and potential energy. Explain the law of conservation of energy or the laws of conservation of energy. Apply the e-learning tools to explore these concepts. Collaborate using online resources like the PhET simulations and Padlet. Work is said to be done when a force acts on a body, causing a displacement. The formula for work is force in newtons times distance in meters. And the unit of work is Newton meters, which gives us a joule. We shall explore a video of someone pushing an object, a PhET simulation of forces and motion basics. We can see the objects are being loaded and the force is being applied. The body is in motion as the force of 209 Newton is being applied. So the body moves a given distance from the gentleman pushing it. So we can measure the distance. The force we saw it as 209 Newton. So we can calculate the distance, determine the work done. Again, is applying another force of 500 newtons on the object. You can see the speed increases. You can measure the distance in between him and the object. Then we can determine the work done in pushing the object. We can load as many objects as possible. Individuals can also sit on that, on the moving object, and we see, or we compare the forces that can be applied whenever objects of different weights are loaded together. We expect different forces to be applied on the body. And also distances will be moved from where the person pushing the object to a given displacement. So that displacement times the force applied will give us what we call work done. So there must be work done in case there is force applied and a displacement on the object being pushed. Therefore, work depends on two factors, that is force and the displacement. Those are the two factors on which work depends on. Explaining the concept of work, we expect to discuss your thoughts on this. Apply the e-learning tools to explore these concepts. Collaborate using online resources like the PhET simulation and the Padlet. Discuss your thoughts on the classroom platform. Our work is done when a force moves an object in the direction of force, and we've already shared this. The formula for work is force times the distance. Exploring calculations on work. Example, a force of 20 newtons moves an object 5 meters. As we've already stated, work is force times the distance. We already know the force, or our force given in an item, is 20 newtons. And the distance or the displacement caused on the body is 5 meters. So we can simply substitute in the formula and we get the answer in joules. So please send your answers or your feedback in the discussion forum. Learners can share their own examples using online platform and share them on the digital platform. When you go to energy, energy is the ability to do work. It exists in several forms: kinetic energy, potential energy, and chemical energy, including others. Kinetic energy, this is energy possessed by a body due to its motion. The formula that involves kinetic energy is a half times mass of the body times velocity squared which is the same as a half mv squared. Potential energy is energy possessed by the body due to its position. By formula, it is mass times acceleration due to gravity times the height. If you abbreviate it, it is mgh. We shall look at the interactive simulation about the energy skate park. You can see the young man enjoying the skate, but as he moves up and down, you can observe that there are changes in velocities, or the velocity possessed by the person enjoying the skate. When observe at the top, the velocity keeps on changing until when it runs to zero. But at the bottom, when observe, the velocity is maximum. So what does that imply? At that point, there is maximum kinetic energy. And at that point, that's when we shall have the skate man. The skate man is velocity running to zero and is at a given height. So at that point, at that position, the skate man will have maximum potential energy. So at this point, this is maximum kinetic energy, maximum potential energy, since the velocity is running to zero and is at a given height. Maximum potential energy. These are different skate simulations that are interactive. I think you will enjoy. You can see the young man enjoying the skate. Potential energy is maximum at that point. Kinetic energy, potential energy at that point. Kinetic energy is maximum depending on the velocity here. Velocity is zero, potential energy is maximum. So at this point, we shall have maximum potential energy. We are having some height from the ground. As we said, potential energy depends on mass, acceleration due to gravity, and height. So we can determine the potential energy of the skate man. At the bottom, at the top, maximum potential energy, and at the bottom we could observe the velocity is maximum, meaning that the skate man possesses maximum kinetic energy and zero potential energy. Since will be from the reference level, the height will be zero, therefore the potential energy will be zero. Potential energy depends on height. If the height runs to zero, then the potential energy also becomes zero. However, when it comes to kinetic energy depends on velocity, and if the kinetic energy will be maximum, where the velocity will be the highest, and that has been evidenced that maximum velocity has been observed at the lowest position, and at the highest position, or at a raised point, the potential energy was maximum and kinetic energy was zero, since the velocity at that position was running to zero. energy cannot be created nor destroyed or transformed into other forms of energy, as we have earlier stated. Either it is potential energy, which will be converted into kinetic energy, or kinetic energy from the bottom where we had a maximum velocity, meaning that it will be maximum kinetic energy. So when the skateman moves from the bottom to the top, then we shall have kinetic energy being converted into potential energy. So at the point where the skateman stops, the kinetic energy will run to zero and the potential energy will be maximum. But now when the skateman is getting back, the potential energy, which was maximum, changes into kinetic energy. So that's how the energy is converted. And we've observed that from the skate park, the roller coaster, energy transformation. Potential energy is at that position is maximum, changes to kinetic energy. Kinetic energy changes to potential. Kinetic changes to potential again in that position. But kinetic at that position is now being converted into kinetic potential energy at the other end. Potential maximum, kinetic at the bottom. Kinetic is maximum at the bottom, where we shall have maximum velocity. So the energy conversions are just transforming from one form to another. We have real-life applications of the energy changes or energy. Energy transformation occurs in daily life. For example, the hydropower, there is potential energy and kinetic energy. Then we shall have those two energies being converted into electrical energy. So, for example, at Nalubari power station, water is used as a source of energy, as you can see in the picture. In this picture here, water is used as a source of energy. Falling water rotates the turbines, which generate electricity. Water is held behind the dam, possessing potential energy. In other words, maximum potential energy. Water will be possessing maximum potential energy as it is being held behind the dam. And at the point of releasing this water, will possess kinetic energy, where it will meet and turns the turbines, creating electricity. For example, at an Nalubari power station, as we can see in the picture. We also have windmills. Moving air has kinetic energy, which is used to move windmills, windmill vanes, and turbines. Modern windmills placed on top of steel towers harvest natural wind and converts it into mechanical energy that produces electricity. These are some of the real-life applications of energy transformation. We shall have an assessment quiz that will be shared under the group or the platform discussions, and I will request that you submit your. Let's enjoy the activity, which will be online, that will be shared in the groups. Tap into the link, enjoy, pass through the activities, and repost back to our group for assessment. You'll get with online, the best thing with online, you'll get the feedback immediately. Thank you. That's the end of this lesson. Thank you for being with us. We love you so much.